morning students. Today's experiment is Titrimetric Analysis. See the board. Aim of the experiment is determination of molarity of KMnO4 using 0.1 molar FAS by volumetric analysis. See here, Titrimetric analysis is the experimental procedure for the determination of concentration of unknown solution by using known solution. Known solution is also called as standard solution. For doing titration, we need three apparatus. First one is burette. See here, this is burette. So another one we need is conical flask. This is conical flask. Then we need pipette. This is pipette. To conduct experiment, we need two solutions. One solution is, see here, this is unknown solution. See the board. Determination of molarity of KMnO4. So this is potassium permanganate solution. We have to identify the molarity of this solution. For this Titrimetric analysis principle is, see, we have to identify the concentration of unknown solution by using known solution. See here, actually we have two solutions. One solution is, see here, this is known solution. The known solution is ferrous ammonium sulfate. Unknown solution is KMnO4. We have to identify the concentration of this KMnO4 solution. See here, for this we are using burette. See the observation. See here, so in the burette we have to take KMnO4 solution. In the conical flask we have to pipette out 10 ml FAS and 1 test tube full of dilute sulfuric acid. And now first part of the experiment is wash the burette, then rinse the burette, then we have to, after washing, we have to rinse the burette because we have to keep the concentration constant. So for this purpose we have to, see here, first wash the burette, then rinse the burette. This is the method of rinsing the burette. After rinsing the burette, we have to fill the burette. We have to fill the burette up to this 0 level. So after washing and rinse the burette, we have to fill the burette. We are filling the burette up to 0 mark, like this. So now arrange the burette to 0. Adjust the level of the burette to 0 mark. That is, we have to see the upper meniscus. We have to observe the upper meniscus for color solution. For colorless solution, we have to adjust the lower meniscus. Here, I am adjusting the burette for 0 reading for upper meniscus. Then keep the burette at burette stand. See here. Second part of the experiment is we have to pipette out 10 ml of, see here, 10 ml of ferrous ammonium sulfate to conical flask. First we have to wash the pipette, then rinse the pipette, then we have to pipette 10 ml of ferrous ammonium sulfate to conical flask. Now see here. Here we have to adjust the level of the ferrous ammonium sulfate. See here, up to this mark. See here, pipette out exactly 10 ml of ferrous ammonium sulfate to this conical flask. After this, you have to add 1 test tube full of dilute sulfuric acid. For this, you have to add 1 test tube full of dilute sulfuric acid. Then start titration. Now listen to me. Initial burette reading is 0. And then we have to start the titration. I am adding KMnO4 drop with drop to the parasammonium sulfate. See, actually FAS is colorless. See, we have to stop the titration after getting permanent pale pink color. The end point of the experiment is permanent pale pink color. We have to do titration until you get permanent pale pink color. See here. See, now listen to me. See here, observe here how I am doing titration. See here. Constant shaking is requirement. Got to shake the conical flask thoroughly. Now listen to me. See here. I am stop the titration. So this is the permanent pale pink color. After getting the permanent pale pink color, you have to stop the titration and record the burette reading. Now see here, I am getting the reading 11. So 11 ml of KMnO4 is consumed for this reaction. Now I will write the final burette reading is 11 here. 11 here. Initially I take 0 ml. So volume of KMnO4 consumed for this experiment is 11 ml. Then again repeat the experiment for 2 titrations until you get concurrent burette reading. Again I am doing one more trial. See here, again we have to do same kind of experiment. Titration. Again I am getting the value 11 ml. Initially I take 0.0. Again I am getting 11 ml. Volume of KMnO4 consumed for second trial is 11 ml. Say, if you not get concurrent burette reading, you have to do one more trial. But here I am getting same 2 readings. If you get same 2 readings, I call this reading as concurrent burette reading. This reading is called V1. V1 is the volume of KMnO4 used for this experiment. That is 11 ml. See here, calculation for this. For trigonometric analysis, we are using one principle, that is A1 M1 V1 na one solution is equal to A2 M2 V2 of another solution. Now here I am using 2 solutions. One is FAS and another is KMnO4. See, we have to find out the concentration of KMnO4. So I take it as M1. M1 is the molarity of KMnO4 solution. So we have to calculate M1. So for this formula is M1 is equal to, see here M1 is equal to A2 M2 V2 divided by A1 into V1. As here M2, molarity of parasammonium sulfate, that is standard solution. Already we know that is 0.1 molar. M2 is 0.1 molar. V2 is, see here, I am prepared out 10 ml of this parasammonium sulfate. So V2 is 10 here. Then, so A1 value is 5. I write here A1 5. So V1 is 11 ml. So I am writing V1 value 11 ml. Then you have to calculate. So calculation is, see now you have to calculate. M1 molarity of this KMnO4 solution is 10 multiplied by 0.1 is, so 1.0181 molar. Therefore, the result of the experiment is molarity of KMnO4 is 0.0181 molar. So, in this way, we determine the molarity of KMnO4 using standard 0.1 molar FAS. Thank you for watching this video.